Welcome back to part 2 on unique logarithmic behavior. We're going to start by using the laws of logarithms to write each expression as a single logarithmic function containing no coefficients other than 1. I'm going to start by taking all my leading coefficients and bringing them up as exponents. Remember, at this point, we are consolidating the function. So we were originally expanding, now we're making it smaller. So all my leading coefficients now need to be exponents. Rewriting this, I'll have negative log base 3 of x raised to the 1/2 plus log base 3 of x plus 1 raised to the 3rd minus log base 3 of xy plus log base 3 of x plus y raised to the 2nd. So I brought up the 1/2 as an exponent, the 3 as an exponent, and the 2 as an exponent. Notice that all my bases match, so I can consolidate this into one logarithm. So I will write this as log base 3, open parenthesis, and I'm going to break this into a numerator and a denominator. My denominator is where all my negative terms, guts, will go. And I say guts just because it's the part inside the logarithm. So I will put the x to the 1/2 in the denominator and also the xy, because these are both leading terms. The sign of the term is negative, so that means they go in the denominator. And the positive terms go in the numerator. So that means I'll have x plus 1 raised to the 3rd and x plus y raised to the 2nd. And so that's my final answer. It looks a little weird. I guess I could simplify it just a little bit more. Log base 3 of x plus 1 raised to the 3rd times x plus y raised to the 2nd. And then in the denominator, I have a x to the 1/2 and an x to the 1. So when you multiply bases, you add exponents. So this would be a 2/2. So I would get x to the 3/2 y. That would be okay as well. Either one of these would be completely reasonable as an answer to a consolidated single logarithmic function. Now let's look at negative ln of yx plus 2y plus 2 ln of x plus 2 minus ln x. Again, I'm going to check that all of my bases are the same, and they are. Next, I'm going to bring up the leading coefficient as an exponent and rewrite. And I'm also going to factor out this y because it's a common factor to both the x and the 2. So I'll have y times x plus 2 plus ln of x plus 2 raised to the 2nd minus ln x. Now I'm going to rewrite this as one natural log. So ln of, and now I'm going to break this into numerator and denominator. In the numerator, I have the x plus 2 raised to the 2nd power. In the denominator, I have y times x plus 2 and also this x. So I'll have y times x plus 2 times x, and in the numerator I'll have x plus 2 raised to the second. And notice that I can actually reduce out an x plus 2. I can't reduce a y. There's no common y in the numerator and denominator, no common x. So I will actually be able to rewrite this in even simpler form. The natural log of x plus 2 divided by the natural log of xy. Let's look at this last one here. We have log of x plus 2 minus log of x minus y plus log of x. So again, all the bases match. I don't have any exponents to bring up front, and so I will just write it as one log. I have positive and negative terms, so I know I'll have a numerator and denominator. In the numerator, I have x plus 2 and x. In the denominator, I have x minus y. And so I'll write this as x minus y in the denominator. And in the numerator, I will have x plus 2 times x. And that's as far as I can go with that one.